So mechanics is the study of motion of bodies, right? So if you look at mechanics itself is divided into, what is mechanics divided into? Huh? Not kinematics. Huh?
Kinetics. Movement.
Dynamics and statics and dynamics, right? You remember you take a course in statics and then you take a course in dynamics and then you come here. And what is dynamics divided into? Kinematics and kinetics. Right? So what does kinematics mean? Kinematics is a study of motion without involving force. When you're studying kinematics, there is no, you're not studying force, or you don't talk about force, right? So, can you study Newton's second law in kinematics? No, because it involves force, right? So when you do kinetics, you have to study about force. Force becomes a one or a quantity of interest. Okay? So this is where, so space mechanics. Now tell me, what is space mechanics? Do you study statics when you study space mechanics? So space mechanics, did you have a chance to go through the syllabus? Did you look at the definition there? Did not take a look at it. So you studied in motion of orbiting bodies. Okay. In this, what you do is you study translational motion. And then you study rotational motion. Okay. So this space mechanics or orbital mechanics is the study of motion of orbiting bodies. Right? So when you start, when this orbiting bodies or orbits comes into picture, how do you define an orbit? Or what does space mean to you guys?
The area outside of the atmosphere.
Outside of the atmosphere, or space. What does space mean? So this thing, you are in aerospace, right? You are the Department of Aerospace Science Engineering. What does aero mean? How do you define the limit of aero and then space? Where?
The atmosphere.
Huh?
Yeah.
So as long as you're under about 150 kilometers above Earth, above the surface of Earth, you study that as aero.
You say 100.
150, 160 actually to be precise. Anything above 160 kilometers is space. Okay. So atmosphere, there are different layers of atmosphere, and there are layers of atmosphere which encompass space. Okay. So this is to put in context where this fundamental space mechanics is in what you're studying. Okay. Now, try to relate physics and mathematics here, right? This, can you relate this to where does it become engineering? What is engineering? Engineering is applied physics and mathematics. Okay? So you apply physics and mathematics to solve engineering problems. Now for that, first you have to study physics and mathematics. Do you study physics and mathematics? Of course you study physics and mathematics. Right? So where does all this statics, dynamics, is it engineering or physics and mathematics?
Physics.
It's actually engineering, right? If you go to the physics department, if anybody majoring or minoring in physics, you'll probably not learn this course. Would you learn engineering statics or engineering dynamics? The course itself is called engineering statics or engineering dynamics, right? What do you apply here? What are the laws you apply here? You studied this, right? Statics and dynamics. You essentially apply the definition of force, you apply the definition of work. Here you apply laws of Newton's laws, right? So that is application of the physics. So physics itself, Newton's laws itself is physics. If you're studying Newton's laws, if you're trying to figure out what are Newton's laws, that is physics. When you take those Newton's laws and start applying them, that becomes engineering. Right? So that's where you have to distinguish, you have to see the connection from how you're taught from high school to engineering. Now when we're dealing with this space mechanics, we're going to encounter a lot of vectors and scalars. Okay? So we'll establish the notation for vectors and scalars so that you guys are clear with that. What are scalars and vectors? Do you understand tell me what is a scalar first?
The scalar is a quantity with only name.
What quantity? What kind of quantity? How do you define a scalar? What is a scalar? Huh? Something, what is that something? She said quantity, it is a quantity, but what kind of quantity? What kind of quantity?
Quantity in no direction.
When you say quantity, you have to be specific. It's a physical quantity. Okay? So it's a physics quantity, right? It's a physical quantity. It's a quantity which has no direction, only magnitude. A scalar is a physical quantity, or you can say a scalar is a mathematical. So what we will learn here is, if you're just talking about physics, we cannot talk about scalars and vectors, right? If we talk about force in the context of physics, unless we make it or express it in terms of mathematics, the scalar, if you understand, this magnitude and direction is math, is arithmetic, right? Can you represent magnitude and direction in physics? You need mathematics to do that, right? So what we do is we identify quantities in physics which can have either magnitude only or magnitude and direction. So scalars and vectors are essentially physical quantities. Scalars, what we are going to do is, so let's say notation this would be a scalar. If I just write the letter, so here A could be, give me an example of A. A could be, huh? Give me an example of a scalar quantity.
No.
Speed.
Huh?
No.
Speed.
Fine.
Speed,
Speed.
right. What else?
Force.
Force is not a scalar. Force is a vector.
Mass.
Oh.
Mass is a vector. Mass could be a scalar. Right. Mass, weight, distance, distance or displacement.
Time.
So these are all examples of scalar quantities. Okay. So A here could be the speed, or speed could be represented by S or V. Any letters you can just use. Letters, just letters by themselves would be used for scalars. Okay. Question? You have a question? No? Now if I do this, A underscore or underline, this would be a vector. Okay. So if I use A underline, that would be a vector quantity. That would be a vector quantity.
Why not over the top?
Hmm?
Yeah. Why not over the top?
I'll come to that. I'll come to that as well. Why not top? I'll show you. So it's again it depends on what you use. If this or this is acceptable. Okay, but try to use this. I'll tell you why. Okay. Now first let us take an example of vector quantities. Vector quantities, force is a vector, right? Force is vector because you need magnitude and there's a direction, right? Huh? Acceleration is a vector quantity. Velocity is a vector quantity, right? So this velocity is the vector equivalent of speed, right? So when you talk about velocity, you have to talk about what direction the velocity is. Okay. All right. So we have talked about scalar vector, something which has only direction, or something which can be used for denoting direction only. What is that called? It's called a unit vector. You have heard about unit vector?
Yes.
So unit vector itself, so what we do is this is denoted for unit vector. That hat on the top is a unit vector. And that's the reason we want to try and use this. Right? So this is a vector, this is a unit vector. And how do you define this A? A is defined as vector A divided by the magnitude of that vector. Right? This is also equal to A divided by pardon? So this would be your unit vector, and this is generally used for representing direction. Right? For example, if you want to point in the direction of sun, you would use a unit vector. Right? Unit vector will have, what is the magnitude of a unit vector? 1. The magnitude of unit vector is always 1. Okay. Yes.
The word next to unit vector is that direction.
Yeah.
Yes, this is direction. Alright, so we'll have to stick to this notation, and when you do your I'm very strict with this. So if you use a scalar, to represent a vector, you lose points. Okay, whether in assignments or in exams. That you have to be very clear. Can one of you pass an attendance sheet? Can you pass an attendance sheet? Give me one sheet, okay? Don't give me two. Don't give me how many? Alright, so these are the notations, okay? Now we will also use one more notation, and that is for matrix. Okay? So if you have double underline, this would be used for matrix. So for example, have you heard about the inertia matrix? We'll talk about it. Now all these, you have to remember, these are mathematical quantities. Okay? What kind of, when we represent vectors, mathematically, how do you write a vector? If you write A is equal to A x I plus right. So what this means is, if you have here this is I, J, T. Okay? So these are the directions, and this is that vector T. Okay? So what it means is this vector A, the component of A in the I direction is AX. The component of A in the J direction is AY, and the component of A in the Z direction is, or K direction is AC. You got it? Everybody is clear with that? That is what it means. And here, what is A? This A, scalar A. The scalar A is essentially the length of this. Got it? So that would be simply square root of ax square plus ay square plus az square. Got it? And this A would be vector A divided by this A. Right? And this A, this unit vector A would be of length 1 in that same direction. Okay? Typically, what's going to happen is this AX, AY, AZ will be numbers, and IJK will be the basis, or in what coordinate system you coordinatize that. Okay? So here we will generally use this notation. AX, AY, AZ. So this means this, it's equivalent of this. Got it? So now tell me, what mathematical quantity is this? It's a column matrix, right? So vectors are represented in column matrices. Okay. Or we could we could also represent something like this: ax, ay, az, and so that means this is the transpose of this. You understand what is a transpose?
When you switch the row and the
Switch the rows and columns. So this is equal to this. So all these rotations. So all these are represent this vector A. Now, if you have something like this, so what this means is, if you use a set of notation similar, or let's say if B is bxi plus dy this means A and B are coordinatized in the same reference frame. You understand? So you're seeing these two vectors from the same reference frame, same coordinate system. Okay, we'll come to this. I will discuss this a little bit in detail. Now, you understand this notation. Everybody is clear with this notation? Right? And what it means, what the vector, scalar and the unit vector mean. That's it. Now we have to discuss operations, vector and scalar operations. So dot product, do you remember dot product?
Yes.
Okay. So you have A dot B. A dot B is defined as scalar A, scalar B, cosine of angle between A and B. So the theta is nothing but angle between A and B. Okay, and this is how you represent it. Cosine of angle between A and B. Okay, that is nothing but theta. If you are given this notation, right? How do you now keep in mind this means dot. This means multiplication. Okay, so you have to be very careful. You cannot use dot here. Don't use a dot here to represent multiplication. You cannot have a dot product between scalars, and that's where if you write this in your exam or in your assignment, you will not get any points for this. You will not get any points for this. Huh? Why?
Because you can't let scalar.
Yeah, this operation is not defined. Right? This operation is not defined. Can you take a dot product between scalars? We cannot take a dot product between scalars. So you have to be very careful in doing that. Okay? If you are given that notation, what is A dot B?
You have to find a magnitude of
It's another square root of
Not square root. So what you do is, yeah, it is
The square root of
Is it square root?
AX
It's ax bx plus
plus
ay by
plus
got it? So this is how you there is no square root. I'll tell you where the square root will come. Okay. So this is how you calculate the dot product if you are given that notation. You just multiply in a matrix form. If you're given this, you just do this into this plus this into this plus this into this. Okay. So this should result, now keep in mind, A dot B will result in one single number. Okay? Will this result in one single number?
Yeah.
It will result in one single number, right? If your AX, these AX, AY, AZ are nothing but there will be numbers. Okay? So this will result in one single number. Now if you look at A dot A, what is A dot A? A square, this will be equal to AX A into AX plus AY into AY plus AZ into AZ. Now here A will be square root of AX square plus AY square plus AZ.
Why are you using a scalar? For that a squared, shouldn't it have underscore under it?
No, that's a scalar. So this is a scalar. Once you do the dot, this will become a scalar. This vector square is not defined. This, there is nothing like this. There is no mathematical quantity defined like that. Okay? So you see where we get that root or A. I told you this definition here itself. Right? How do you get that definition is here. Now similarly, cross product is defined as A dot B is equal to, again, A, B, sine of angle between A and B, and what you need is a vector. You need a vector. So this, cross product. Okay. Yes.
So can you write the A dot B using that?
Which one?
Can you
This
write-
one?
Yeah, using that, or is that's just wrong?
You cannot use this because, see here what I did was, this is A square, right? So A dot B is AB.
Oh, never mind, I see it now.
You see it?
Yeah.
So this A cross B is AB sine, you remember this definition? And you need a vector which is perpendicular to AB. When you take the cross product will result in a vector. Got it? So here what you need is so let's call this. Okay? What this means is, if you have let's say this is A, this is B, right? If you do this, you get the projection of A on B. Okay? and the length of that. When you do this A cross B, what does A cross B mean? We'll stop after this. A cross B means this vector, the vector coming out of, or actually going inside the board. Okay, that vector is this A cross B.
So the normal.
And you said dot is what?
Huh?
What was dot P? Say it again. I'm sorry.
So here, let's do this.
It's the normal vector.
Oh, okay.
A, B. So this vector, A cross B is a vector. That vector is this. My marker is the vector. So A, right, you have, this is an A cross B vector. And this will be perpendicular to both the A and B vectors. Do you see this as perpendicular to both A and B? Right, this angle 90 degrees, this angle is 90 degrees. So this cross product vector is always a vector perpendicular to those two vectors. And the magnitude of that, the magnitude of this vector is given by this. A, magnitude of A, magnitude of B into sine of this. So if you are given in that terms, how do you calculate that? How do you calculate if you are given that notation, A cross B? You remember? So you have I, J, K, then you have AX, AY, AZ, DX, DY.
And then you do the determinant, right?
Yeah.
Huh?
You do the determinant.
You do the determinant. You're right. So you have I into AX,
Times AY. AY.
AY into BZ minus BY into AZ. Correct? So you forget this one and this one. You do this minus this. Plus J into. So you remember this.
Yes.
Okay. So this is how you. Now you see, this will result in one number, but this will result in another vector. You see? Yes.
This class is from 9:30.
This class is till 9.
It's 9.
Sure. That's
No, but is it possible we just have like to 9:30 Tuesdays and Thursdays?
No, I think some of you have a class at 9. Right?
Someone have a class at 9.
Do you guys have a class at 9? I really wanted to do that, but Nick, you have a class at 9? On Thursdays you have a class at 9. Right. I think Dr. Ali's class. Yeah. This is a very odd timing actually. One here, and one on Wednesday, 3 to 4. Somebody, you had a problem?
I have a
Okay, I'm sorry for that, but that was the only other option.
No, it's fine.
I literally went and ticked all your schedules, and these were the only time slots which were available. So again, this time is remember the time: 8 to 9 on Tuesdays and Thursdays, and 3 to 4 on Wednesdays.